First thing about this talk, we'll start with who I am. My name is Heungsoo. I work for Line. And as you all know, it's a mobile messenger, and we have lots of services, including cryptocurrency exchanges. And we care about security very much. We have lots of security researchers in our company. So as we all heard Philip's talk today in the morning, Coinbase was attacked, and attacked by a very sophisticated, highly targeted attackers. And it was released in Coinbase blog by Philip Martin himself. And there's a decent analysis on objectc.com about the malware. And it's not disclosed, but Line was also targeted. And this talk is about the same campaign and how it looked to us and how we dug into the attackers. So the goal of this talk is first to share the perspective of the victim, how it looked like him, how normal it looked, how unsuspicious it looked, and the perspective of the attackers, what they had to prepare, what kind of engagement they were in, and the perspective of the blue team, which is us, what we could see and what we could not see. And also share some information about the malware they used and a little more about the attackers themselves. So the first is the victim. A little bit of information about the victim is he is a very talented developer. He worked in global companies in Silicon Valley. He has more than a year of experience. And he was using iPhone and MacBook Pro for his work and his personal computing. So the attack started from an email conversation, just like Coinbase case. So one day, the victim gets an email from, in this case, nm603@cambridge.ac.uk. So he got it to his personal account, which is Gmail. And if you see the sender, it is legit from Cambridge University. We looked at the email headers. It passed all the security measures like SPF or DKIM, DMARC, etc. So it was legitimately sent by the Cambridge email server. And there's a link at the content to the Cambridge University, which is just a normal page talking about the award, which is, they called it Adams Prize, which is a real thing. They are looking for field experts like you, and we could get some help. He introduced himself as an organizer of the prize. And if you look at the email, there's a LinkedIn profile link. So if you click it, there's a guy shows up in LinkedIn named Neil Morris. He has more than 100 connections, and his careers fit to the story very nicely. At first, we actually thought this guy was real, and he was being impersonated. But turns out this profile itself is fake. So victim has no doubt at all. He shares conversation through email. Oh, what kind of help do you need from me? And Neil Morris guy replies, we'll arrange what we need from you and get back to you. And after some conversation, they sends a link to the victim, which is also inside the Cambridge, and he gives a login ID and password. Please log in with this ID and password, but this is a temporary password, so you need to change it after you log in for security. So he visits the link to see the message that browser is not supported, that he should use Firefox. So the link to the Firefox is really official Firefox download page. This used to happen a lot back in the times when browsers only, web pages only support Internet Explorer or vice versa. So the victim thought, yeah, why not? So he downloads Firefox and uses it to browse the same page, and the web page shows up. There's an ID and password form, and he tried to log in with the given ID and password, but the login didn't work. This page actually is ripped off from the actual Cambridge login page. So at this point, the victim's machine was exploited, and Firefox shellcode ran inside Firefox, and the shellcode used curl or CRL to download the real malware to avoid macOS gatekeeper, which means if you use your browser to download an executable and try to execute it, the gatekeeper will block, wait, this file is downloaded by this browser. Do you really want to execute it? But if you use a tool like curl or wget and execute it, the gatekeeper won't show any message. So they actually, from the shellcode, they used curl to download the malware and executed it. So fortunately, in our case too, the attack was stopped here. It was detected, and there were mistakes they made where they could have done better. But those raised some flags, and we could detected it. We used some indicators and in-house tools to stop the attack here. So what did we do with the victim? We started interrogating him. Why did you do that? Why did you put our company in danger? And of course, this is a joke. We talked to the victim, and he helped us a lot to investigate what actually happened. So security team followed up. We did some tracking, what happened, where was the attack from, and how did the malware get downloaded, and we made some fake environment to run the malware to see what they do, and it actually downloaded stage 2 malware after some time, just like Coinbase. So afterwards, the malwares were tagged as NetWire variant and MOX variant. The names actually don't matter really much, but it helps when you track down the same campaign from the same attackers. So the second perspective is the attackers. What did they really do to prepare this attack? First, they would have to prepare weapons. They would prepare weaponized exploits, in this case Firefox. And of course, all the modern browsers have sandbox in their system. So they would need at least two weaponized exploits, first for code execution, and second for sandbox escape. And they will have to prepare malware. It is very common in malware campaign and APT campaign to divide stages on their attacks. So for the stage 1, they're responsible for, it's like a scout. They're very small, they're very low detected, and they are for reconnaissance. They want to look for what kind of victim is security product he's using, etc., etc. And stage 2 was the full RAT, or remote administrator tool. And they will have to prepare infrastructure or servers. They separated all the servers into, all the roles of servers into multiple servers. So they use different servers for C2, and use different servers for hosting malware, and use different servers for hosting exploits either. So for C2, they used QHoster in Uruguay. For stage 2, C2, they used LeaseWeb from UK or DigitalOcean from US. To host malware, which means the server where the shellcode used to download the malware is from Russia. And they hosted their exploit in ovh.com, which is in France, and they bought a domain, analyticsfit.com. And all these VPS services, they accept credit cards, PayPal, Webcash, and of course Bitcoin. And they hacked accounts. They hacked accounts to use for the attack. They hacked at least 2 accounts from Cambridge, which is NM603 and GRH37. The methods for hacking these accounts were not disclosed. They never announced it. It might have been phishing or credential stuffing, which means using leaked ID and password, or it could have been brute forcing, or there could have been a bug in their web page codes, or they could have just dumped DB, compromised the whole DB, where if there was a bug in their database management system, like SQL injection. And if you get an account to a university, you of course get the email access. And commonly, you get another very nice feature, which is a personal web page hosting service. And you can search every account in Jackdaw, which is very good for OSINT. So if you search, it's at jackdaw.cambridge.ac.uk, and anybody without any accounts can search everybody. So if you search A, it'll list all the accounts starting with A. And of course, our victims are searchable too. So not only email addresses, they give you personal web page hosting, which is people.ds.cambridge.ac.uk. And if you add your ID at the end, that's your personal page. It's a very common feature in universities where you can host your profile, your research, your papers, and everything else. So they use these features to make it very look legit. The email domain was Cambridge, and the page domain was Cambridge too. That gives very big authenticity to the attackers. And they will have to prepare the website, the fake web page, to be shown for the victim. They actually they used the real page from Cambridge and added some simple HTML code and JavaScript code for their own purpose. And they added a simple code and layer to show, please use Firefox to browse this page, and they added a link to the exploit. So this is part of the script on the fake website. The JavaScript checks the operating system and browser. So if it's using macOS but not Firefox, it'll show, please use Firefox to browse this page. And if the victim or the visitor is using macOS and Firefox, it will show the web page and load /script.js from the server. So this must be the exploit. That's what I thought. Yeah, it loads this /script.js. It should be the exploit. But turns out it was not. It returned 404. It was not there. It could be a fake code, or it could be a leftover from their previous campaign. So it could be a fake like this. The actual exploit was at the end of the HTML page, where they added loading a JavaScript from analyticsfit.com. Almost every website has a Google Analytics JavaScript at the end of their page, and they wanted to make it look just like that, so nobody would, suspect it. And the traffic is using HTTPS. And after grabbing university account and preparing university fake websites, they will have to prepare John Doe. Because they got the account named NM603 and GRH37. They made up their fake identity with Neil Morris and Gregory Harris. And they joined LinkedIn and make a profile to fit the story nicely. And they added connections. And if I get a connection request in LinkedIn, I just accept every request. Maybe that's how they got so many connections. And of course, they will have to write a nice email signature to look it very legit. Then they could start operation. They could look for targets to send emails, look for cryptocurrency employees, and start by opening conversation through email. And during the conversation, they evaluate their targets. They don't send out their exploits to everyone, just like Philip mentioned. They guide only selected targets to the exploit page. There's another case on the internet, a guy named Robert Heaton. He also talked to the same email attackers. And this blog is about how he almost got hacked. So he talked to GRH37 at Cambridge, and he was never guided to the final exploit page. So he was actually initially selected as target, but he was faded out. He was evaluated out because he works in financial IT, but turns out he works for a payment company, so they were not interested. So he uploaded a screenshot of the email conversation. You can see the Gregory Harris guy is saying, we'll come back to you with more information. And he never heard from him again. The funny thing is, he wrote in his page, after he found out everything happened, why doesn't he just please use Firefox? I would have definitely used Firefox. But they actually do, but he never got the chance to see it, which is this page. So after exploiting the machines of cryptocurrency employees, the goal would be running stage 1 malware and running stage 2 malware and go for the profit. Now is the perspective of the blue team, which is us, what we can see and what we cannot see. It's very cliche to say there are too many stuff to watch for the blue team, yes, and there are too many flags that are raising, like false positive flags. We have very many employees from many countries. We have huge infrastructure. We have our own AWS-like system. Our researchers can launch VMs of numbers of their wish, as many as they want. So we have lots of servers inside. But we do have some ways to protect ourselves. From infrastructure level, we can monitor network packets. And there are some solutions that offer visibility on HTTPS connections, which I don't like. And from the endpoint, we can detect what's running inside our colleagues' computers. What's just like an EDR or antivirus. And there are patch management system, and there are various monitoring solutions, etc., etc. And we can run honeypots and sandboxes inside our network, and we can pay for IOC or indicators of compromised service. We can apply network segregation or air gapping to harden our internal network. And we can apply two-factor authentication for better authentication. And more. Of course, we can apply everything, but we have to find a point where we don't harm the productivity of our colleagues. If you apply everything, your colleagues are going to hate you. And the pain point for Blue Team in this case is that the attackers send email to victims' personal Gmail account. And in our mail server, we don't have the email to look over. And they used real Cambridge servers and website, which is very not suspicious. They used HTTPS connection with encrypted communication for their malware. And the stage 1, stage 2 malware had very low detection. The stage 1 malware had 1 detection based on virus total from a Chinese vendor, and stage 2 had 0 detection. And the communications are all encrypted and connected to port 80 or port 443. And like I shared, they use diverse use of servers. They split everything into multiple IP addresses, multiple countries. And I'm not sure if this is a coincidence or they were after this, but the stage 1 did not download stage 2 for a while. And after I set up a fake environment that looks like a corp environment, I brought the laptop home, and I could see that stage 2 downloaded then. So they might have been waiting for the employee to move outside the company, or it could be just coincidence, who knows. And some breadcrumbs for blue team. What we could see, the shellcode used curl to download Macro binary directly, and it was not encrypted. So in the network level, we could see a Macro binary being downloaded and executed from the endpoint. And the communication was made to suspicious IP addresses, which is not bound to any domains. And there were new executable files with a very suspicious name, which tried to look like a normal Apple daemon service. And we had security team resource to follow up. Plus some other indicators that I would not like to disclose, because they could, after they see it, they could just apply to their next campaign, which would help them. A little bit about the malware. The stage 1 is NetWire variant. NetWire is a commercial administration tool. You can buy it online. And it's basically agent builder. So if you put like C2 or password or anything of your options inside, and you can build a client binary. And this is a screenshot from YouTube because I didn't want to actually buy the product. This is a hash of the stage 1 binary, and it was downloaded from that server with the name of Icon Services Agent, which is a Apple macOS daemon name, which is very suspicious. And the C2 server is that one, but the port is now closed. And the binary is not signed. Their previous campaign, they liked signing their binaries with a legit, but with a certificate that looks like they bought it somewhere. And this time they didn't sign this binary. The C2 protocol is known and is uploaded in GitHub, but it looks either the protocol on the page is old, or they made a modification on their version, because XOR, they used an XOR to the known command. These are some common features of APT malware, but I'd still like to share. They can report the user information, host information, information about the network, and they try to find out the external IP address of the victim through checkip.dydns.org. So with that, the attackers could know where the victims work. If the IP address shows to Line or Coinbase, they will know where the victim is located. And of course, it could list process, and they could start a shell to accept any commands. They could search or write or execute any files. And of course, there's heartbeats, sending server reporting that I'm still alive. So this is the actual packet capture from the stage 1. And the first part, the red part, is the part where the malware reports that I'm started executing. And the first command is to report system information. And the big red part is the system information. And after that, it's just heartbeat, just sending I'm alive, I'm alive. And for persistence, it uses launch control, which means it will try to execute again after reboot. It will show in user login items. And it adds itself to signal handler, which means if something happens and process crashes, it still wants to restart its process again. And the shell, remote shell function I showed, it uses bin shell, and it'll leave shell history to the disk. So actually, shell history was left to the fake machine. If you see after it downloads stage 2 malware, it will move to temp directory and add executable access to the binary and run it. So this was actually the history of the attacker. And in the stage 1, there's a unique string, HYD7 ... It's a RC4 key they use to decrypt a rand, a string named %rand. And I'm not sure if it's not changeable or they just don't change it, but this string is being used over and over again. So if you Google with this string, you'll get some analysis report from security researchers from Poland or Turkey and in Japan, a nice one in LAC. So for the stage 1 server, I brute forced the server to see if there's other binaries, and I could get some. And I used like a dirb derb, and after that I used a Python script to brute force download anything from the server, and I could get some variants from the server. They all have same code, they just have different data because of different RC4 key. But still, they all have height 7 string. These are the hashes for new variants, and I uploaded it in VirusTotal, and you can download here for research. And for stage 2, hashes as follows. It was downloaded by stage 1 after some time. It's Moke's variant. It's a full remote administrator tool with C2 server as follows. The servers are all alive, but the ports are closed. Second one has an open port, but it's not sending any payload. And the second one's digital certificate is invalid. Maybe it's been sinkholed by some security firm. An overview of the stage 2, it was built with Qt. So it's a Qt binary, and it's a very huge binary. It's 13 megabytes. So I tried to add signatures on Qt libraries, OpenSSL libraries, Cocoa, anything that's macOS related, and I could only identify only 20% of the binary. So it's too much binary to look at. And this was not signed either. Some features of the binary is it copies itself to randomly one of these names to look normal. And also it uses launch control for persistence. And it hides itself from macOS dock, which means because it's a Qt binary, simple hello world will show at the macOS dock. So this will be visible to the victim, so they added environment variable to make it go away by Qt. And it looks for files like doc, docx, or Excel files. And if you see the function name, I added this screenshot because they either accidentally or intentionally made this function exported, which means this function function name is named by the attackers. It was the actual function name from the source code. And more about the campaign, connecting dots on their work habits. So they didn't have names until recently, and after CoinCheck, some of the Japanese security firms like LAC named them Hide7 from the string, RC4 key string. Other than that, they don't have a name. They are known for attacking banks and attacking financial businesses of unknown names. And they were introduced in FireEye. There's a nice overview from mertsarika.com. He's a Turkish guy, and I met him last month and talked to him, and he shared about how they're active in Turkey attacking banks. And there's another analysis document from Exatel, which is Polish, and LAC Watch also wrote a nice report on CoinCheck hack. They like to use spear phishing for opening their campaign. So they use like Office document with macro, and they use Office one-day exploit, or they use WinRAR exploit, and in this case they use Firefox zero-day exploit. And they have a history of using Windows zero-day elevation of privilege exploit too. And they really like hacking universities. In this case, they hacked London School of Economics account, and they used the email for communication, saying I'm an organizer of a prize, and we're looking for experts like you for banker awards. Same thing. And they use universities' web hosting too. They really like it. In this case, this was Miami University, and they hosted a document file, Word file, and it was embedding macro or EPS exploit on this document. And they're not afraid of making conference calls. They actually call the victim and guide them to please enable the Office macro, or hey, I'm the guy who sent the email. And this calling the victim gives them pretty much credential. And their favorite method is use LinkedIn to increase the credibility. This case, they impersonated someone with a similar name. So they hacked account of a London School of Economics. The account was M. Salavaggio. And they found a guy in LinkedIn, Matteo Salavaggio, and they added a link to this guy's LinkedIn page. Actually, he's from a different university, but not many people look deep into these. In this case, they hacked Angelina College. And their favorite VPS is OVH from France, LeaseWeb from UK, King servers from Russia, and not the King servers, just the first two, France and UK. Their previous campaign, they used OVH and LeaseWeb for 6 times at least. And the other services, they only used once. So why him? At first, I thought they were after our cryptocurrency exchange. And then another idea came that because only one guy was targeted in our case, unlike Coinbase. They initially sent email to 200 employees. But in this case, in our case, it was just one guy. So why one guy? Did they not find employees of Line online? But it's pretty easy to find Line employees working for cryptocurrency. So was it attacking exchange, or were they attacking individual? Because they were known for attacking individuals that looks like to have many Bitcoins. So if somebody is posting a cryptocurrency forum that he's doing autonomous trading bot. They attack him to get bitcoins out of him. So, conclusion about the attackers. They have a very good skill on social engineering. They use compromised university accounts for email and website hosting. And they are very responsive on communication. They reply very good. And they even call you with their own phone. And they use zero-day or end-day exploits, or just Office with macro. And their malware is Netwire and Mox, and they manage their malware binary to have very low detections, and they use digital certificates to sign their binaries. And their malware are platform independent from source code levels. So they have malware running on Windows, running on Mac OS, and running on Linux too. And they're very active, and they're very skilled operators. And for countermeasure, how can he prevent or block such kind of attacks? It's a very difficult question because such a discrete attackers, at some point we are supposed to fail. For detections and sensors, we have to use all the information we have from endpoint protection or network and write our own honeypots or use solutions, use indicators of compromise, and use human resource like researchers. And we should apply defense in depth, of course. We can't, if we didn't block the attackers at some point, we have to block it and block them in another point, somewhere at some time. And of course, user education is very good to block spear phishing. In our case, it was 0 days. And another case is that we could see use of Office with macro files. And it's a very suspicious to force email receivers to allow macro execution. But still, many people fall for that. So we should minimize the risk while maintaining usable security. So that was my introduction about these attackers, and that's my contact. If you have any questions, I'm here, or I'll be here all day.
ありがとうございました。